we discuss about the topic application of derivatives. Application of derivatives. Now in that, if suppose y equals to f of x is a function, y equals to f of x is a function. Now delta x is error in x. Now the corresponding error in y is delta y. Corresponding error in y is delta y. Now f of x plus delta x equals to f of x plus f dash x into delta x. F of x plus f dash x into delta x. Now similarly, if suppose delta y is error in y, then delta y by y is called relative error. Delta y by y is called relative error in y. Similarly, delta y by y into 100 is called percentage error. Percentage error in y. Delta y by y is called relative error. Delta y by y into 100 is called percentage error in y. If suppose x is a variable, now dx by dt is called rate of change in x, rate of change in x with respect to t. Dx by dt is called rate of change in x with respect to t. Similarly, if suppose y is a function, dy by dx equals to rate of change in y with respect to x, Now, if suppose a particle traveled at a distance s in time t, now the velocity of the particle v equals to ds by dt, velocity of the particle equals to ds by dt. Similarly, acceleration a equals to dv by dt or d square s by dt square. D square s by dt square is acceleration of the particle. Next, if suppose x axis, y axis, there is a curve. Consider the curve equation y equals to f of x. Y equals to f of x is a curve. Now there is a point P. P x1 y1 is a point on the curve. Now if suppose a tangent to the curve meets x axis in t, tangent to the curve at the point P x1 y1 meet the x axis at t. Now it is tangent. Now a line perpendicular to tangent is called normal to the curve at the point P. Now a perpendicular is drawn from P to x axis. If suppose this point, consider n, PQ perpendicular to it. Now the distance between P and T, now PT is called length of the tangent. Now length of the tangent equals to y1 into square root of 1 plus m square by m, where m equals to dy by dx at x1 by 1. Now m equals to dy by dx at x1 by 1, it is nothing but slope of the tangent. Similarly, Pn equals to length of the normal, that equals to y1 into square root of 1 plus m square. Length of the normal, length always positive quantity. Now Pn is called length of the normal. The distance between P and N is called length of the normal, that equals to y1 into square root of 1 plus m square. Next to Qt equals to, Qt is called length of the subtangent, length of the subtangent. Now that equals to y1 by m. Length of the subtangent Qt equals to y1 by m. Next to nq equals to length of the subnormal, length of the subnormal. Now that equals to y1m mod. nq equals to length of the subnormal, that equals to y1m. Now we discuss some problems on the chapter. First problem, the approximate value of tan 45 degrees 1 minute, given that 1 degree equals to 0.01745 radians. Now required the value of tan 45 degrees 1 minute, tan 45 degrees 1 minute, its value. Now if suppose consider f of x equals to tan x. Now for implies f dash x equals to secant square x. F of x equals to, consider tan x, for implies f dash x equals to secant square x. Now f of x plus delta x, f of x plus delta x equals to f of x plus f dash x into delta x. Now f of x plus delta x equals to f of x plus f dash x into delta x. Now consider here f of x plus delta x equals to, here f of x equals to tan x, f of x plus delta x equals to tan of x plus delta x equals to f of x tan x plus f dash x secant square x into delta x. Now consider x equals to 45 degrees and delta x equals to 1 minute. But 1 minute equals to 1 by 60th degrees. But 1 degree equals to given 0.01745 radians. Now 1 minute equals to 0.01745 by 60. 0.01745 by 60 radians. Now tan 45 plus 1 minute equals to tan 45 degrees plus secant square 45 into 0.01745 by 60. Now that equals to tan 45 value 1, secant square 45, secant 45 equals to root 2, secant square 45 2 into 0.01745 by 60. Now that equals to 1 plus 2, 30 times cancel. Now divided by 30, we get 0.00058 approximately. That equals to 1.00058. Now the value of tan 45 degrees 1 minute equals to 1.00058. Now fourth option is correct. Fourth option. The percentage error in the period of a simple pendulum is approximately equals to. Now time period t equals to 2 pi by under root of Lg, where L is length of the pendulum, G is gravity. G is the gravity. Now 2 pi constant g also constant. If suppose y equals to x power n, y equals to x power n. Now delta y is error in y and delta x error in x consider. Now percentage error in y equals to delta y by y into 100, delta y by y into 100. Now that equals to delta x equals to, or that equals to delta y equals to, or dy equals to, differentiating with respect to x on both sides, we get n into x to the power of n minus 1 into 100 by into delta x by y equals to x power n, x power n. Now that equals to, here x power n minus 1 cancel, in denominator x will get. Now n into delta x by x into 100, delta x by x into 100, or that equals to n into percentage error in x. Now percentage error in y, if suppose y equals to x power n, y equals to x power n. Now percentage error in y, percentage error in y equals to the exponent of x, the exponent of x into percentage error in x, percentage error in x. Now y equals to x power n, then percentage error in y, percentage error in y equals to n into percentage error in x. Now here t equals to 2 pi by root g, that is constant, 2 pi by root g into L to the power of 1 by 2, L to the power of 1 by 2. Now percentage error in t, now percentage error in t equals to percentage error in t equals to the exponent of L 1 by 2, 1 by 2 into percentage error in L, half into percentage error in L. Now third option is correct. If the radius of the circle, if the radius of the circle equals to 2.1 centimeters, 2.1 centimeters, then the approximate area of the circle. Now area of the circle, consider A, radius of the circle R, then A equals to pi r square, area of the circle formula pi r square. Now required approximate area, now A equals to pi r square. Now A plus delta A equals to pi r square plus derivative of pi r square 2 pi r into delta r, 2 pi r into delta r. Now consider r equals to 2 and delta r equals to 0.1 centimeters. Now approximate area of the circle equals to pi r square plus 2 pi r into delta r. Now that equals to pi into r value 2, r square equals to 4 plus 2 into pi into 2 into 0.1. Now that equals to 4 pi plus 0.4 pi. Now by adding both 4.4 pi squared centimeters, the approximate area of the circle equals to 4.4 pi squared centimeters. Now second option is correct. If there is an error 1 by 10% in the measuring radius of a sphere. Now given percentage error in R, radius of a sphere is 1 by 10, then the percentage error in the calculation of the volume of the sphere. Now volume of the sphere equals to 4 by 3 pi r cube, 4 by 3 pi r cube. Now here 4 by 3 pi completely constant. Now percentage error in V, percentage error in V equals to 3 into percentage error in R. 3 into percentage error in R. Now, but percentage error in R equals to given 1 by 10. That equals to 3 into 1 by 10, or that equals to 3 by 10. 3 by 10% in calculating volume. Now, first option is correct. If error of 1% are made in the base radius and height of a cone, then the percentage error in its volume, Now, volume of the cone equals to 1/3 pi r square h, Now, required percentage error in volume, percentage error in V equals to, here 1 by 3 pi is constant, then only 2 into percentage error in R plus the exponent of h is 1. Now, 1 into percentage error in h. Now, but given in problem given the percentage errors in base radius and height of the cone both are 1, that equals to 2 into percentage error in R 1 plus 1 into percentage error in h also 1. Now, 2 plus 1, now 3%. Now, fourth option is correct. The area of the triangle is calculated by the formula delta equals to half AB sin C. If delta C is the error in measuring the angle C, then the approximate error in area, only required approximate error in area. Now, delta required, that equals to half into AB into sin C derivative cos C into delta C. Now, the approximate error in area of the triangle or delta equals to half AB cos C into delta C. Now, second option is correct. If the area of the triangle calculated by measurements of B, C and capital A, and K is the error in A, means delta A equals to given K, then the percentage error in the area, Now, here B and C are lengths of the sides, capital A is angle between the sides B and C. Now, area of the triangle delta equals to half BC sin A, Now, required percentage error in area of the triangle, Percentage error in area of the triangle nothing but delta by delta into 100, required delta by delta into 100. Now, delta equals to differentiating with respect to both sides. Now, that equals to half BC into sin A derivative cos A into delta A. Now, that equals to half BC cos A, but error in angle A equals to K given. Now, into K. Now, required percentage error in area of the triangle, that is nothing but delta by delta into 100. Now, delta by delta into 100, that equals to delta equals to half BC into K cos A by delta equals to half BC sin A into 100. Now, half cancel, BC also cancel. Now, that equals to K into 100K into cos A by sin A. that equals to nothing but cot A. Now 100k cot A is the percentage error in area. Now second option is correct. Second option. If in a triangle, the sides of a triangle and side of a triangle A and angle capital A remains constant, while the other elements change slightly, slides changing. Now required condition. Now if suppose triangle ABC, in triangle ABC, length of the side BC equals to small a, CA equals to small b, AB equals to small c, because opposite to angle A side small a, opposite side to angle B small b, opposite to angle C small c. Now here angle A and length of the side BC both are constants, means B and C are changes, but sum of angles in a triangle A plus B plus C equals to 180. Now angle A given constant, angle A is constant, no change in angle A. If suppose B and C are changes, if suppose B increases, then C decreases, B increases, C decreases. If suppose delta B equals to, or change in B equals to 1 degree, then delta C equals to minus 1 degree, because A plus B plus C always constant or 180. Sum of angles in a triangle equals to 180. If suppose angle B increases 2 degrees, angle C decreases 2 degrees. Now always sum of changes in B and C, or delta B plus delta C equals to 0. Delta B plus delta C must be 0. Now sum of changes in B and C must be equals to 0. Now from sine rule, B equals to 2r sin B, C equals to 2r sin C, B equals to 2r sin B, C equals to 2r sin C. Now delta B equals to 2r into cos B delta B. Similarly, delta C equals to 2r into cos C delta C. Now delta B by cos B plus delta C by cos C equals to, remaining terms 2 are common, 2r into delta B plus delta C, but delta B plus delta C equals to 0, then delta B by cos B, it is nothing but delta B into secant B plus delta C into secant C equals to 0. Now the required condition, delta B into secant B plus delta C into secant C equals to 0, then third option is correct. Third option. If ABC are sides of a triangle ABC, then delta A by cos A plus delta B by cos B plus delta C by cos C equals to delta A by cos A plus delta B by cos B plus delta C by cos C. Now triangle ABC. Now small a, small b, small c are sides of a triangle, ABC. Always sum of angles equals to 180 degrees. Sum of angles equals to 180. Now the sum of changes delta A plus delta B plus delta C also equals to 0. If suppose two angles increases 1 degree, third angle must be decreases 2 degrees, because sum of changes must be, or sum of errors in the angles equals to 0. Delta A plus delta B plus delta C equals to 0. Now from sine rule, A equals to 2r sin A. For implies delta A equals to 2r cos A into delta A. Similarly, B equals to 2r sin b from sine rule. Delta b equals to 2r cos b delta b. Small c equals to 2r sin c from sine rule. Now delta c equals to 2r cos c into delta c into delta c. Now delta a by cos a plus delta b by cos b plus delta c by cos c equals to, in remaining terms 2r take common, we get delta a plus delta b plus delta c. Now but delta a plus delta b plus delta c equals to 0. Now this completely equals to 0. Now first option is the correct. If y equals to x power n, then the ratio of relative errors in y and x, now relative error in y equals to delta y by y, relative error in x delta x by x, required the ratio means delta y by y is to delta x by x is the required. The relative error in y is to relative error in x required. Now differentiate, we get delta y equals to n into x power n minus 1 into delta x. Now delta y by y equals to, here delta y equals to n into x power n minus 1 into delta x by y equals to x power n. Now delta y by y equals to n into x power n minus 1 by x power n equals to 1 by x into delta x, or that equals to n into delta x by x. Therefore delta y by y, it is nothing but a relative error in y. Relative error in y equals to n into relative error in x. Therefore delta y by y is to delta x by x equals to n is to 1. Now fourth option is correct. The distance travelled by a particle in time t is given by s equals to 2 plus 3t minus t square plus t cube. The velocity when the acceleration is 0, required the velocity of the particle when the acceleration is 0. Now first velocity v equals to ds by dt. Now that equals to, differentiating with respect to t, 0 plus 3 minus 2t plus 3t square. It is velocity of the particle. But acceleration is 0. Acceleration a equals to rate of change in velocity or dv by dt. But dv by dt equals to minus 2 plus 60. It is equals to 0, then t equals to 1 by 3. Then acceleration is 0. T equals 1 by 3, acceleration equals to 0. But acceleration is 0, required velocity. Now v at t equals to 1 by 3. Or ds by dt at t equals to 1 by 3. But ds by dt equals to 3 minus 2t plus 3t square. 3 minus 2 into 1 by 3 plus 3 into 1 by 3 whole square. Now that equals to 3 minus 2 by 3 plus 1 by 3. 3 minus 2 by 3 plus 1 by 3. Or by taking LCM as 3, 9 minus 2 plus 1, 10 minus 2, 8 by 3. Velocity equals to 8 by 3 units per second. Third option is correct. Particle is projected vertically upwards. Its height h at time t has the relation h equals to 60t minus 16t square. 60t minus 16t square. The velocity at which it hits the ground. It hits the ground. If suppose a particle or a stone thrown vertically upwards, it reaches at maximum height, its velocity equals to 0. After that, it freely fallen on the ground. At the ground, same velocity, means at the time t equals to 0, the velocity at the time t equals to 0, same as the velocity on the ground. Now, h is displacement of the particle. Now, dh by dt, required dh by dt at t equals to 0. Now, dh by dt equals to 60 minus 32t. Now, dh by dt at t equals to 0, 60. Now, answer is 60, third option. A particle moves according to the law S equals to t cube minus 3t square plus 3t plus 12 plus 3t plus 12. The velocity when acceleration is 0. Required velocity when acceleration a equals to 0. Now, first velocity v equals to ds by dt, or that equals to 3t square minus 60 plus 3. Now, velocity of the particle equals to ds by dt, that is nothing but 3t square minus 60 plus 3. Now, acceleration a equals to dv by dt, rate of change in velocity. Acceleration a equals to rate of change in velocity or dv by dt, that equals to 60 minus 6. But given velocity acceleration equals to 0, then t equals to 1. Now, t equals to 1. Required velocity of the particle when acceleration is 0, but at t equals to 1 acceleration is 0. Now, required velocity at t equals to 1, vt equals to 1, that equals to, but velocity equals to 3t square minus 60 plus 3. Now, t equals to 1, substitute in the velocity, 3 into 1 square minus 6 into 1 plus 3, or that equals to 0. The velocity at t equals to 1 is 0. First option is correct. The velocity v and the distance s, travelled by a particle has the relation 2 plus 3v square equals to s square. 2 plus 3v square equals to s square. Then acceleration is, required acceleration. Here given v is velocity, s is displacement. Now, required acceleration of the particle. Now, differentiating with respect to t on both sides, d by dt of 2 plus 3v square equals to d by dt of s square. Now, differentiating with respect to t, now 6v into dv by dt, 6v into dv by dt equals to 2s into ds by dt, Now, here v is the velocity, then rate of change in velocity or dv by dt equals to acceleration. Now, 6v into dv by dt equals to acceleration a, that equals to 2s into ds by dt, rate of change in displacement equals to velocity, or ds by dt equals to v. Now, both sides v get cancelled. Now, acceleration a equals to 2s by 6 or s by 3. Acceleration of the particle a equals to s by 3. Third option is correct. A stone projected vertically upwards moves according to the law s equals to 48t minus 16t square. 48t minus 16t square. The greatest height reached. Now, a stone projected vertically upwards. If suppose it reaches maximum height, at maximum height, the velocity of the stone equals to 0. The stone projected vertically upwards. Now, at if suppose the stone reaches at maximum height, the velocity of the stone equals to 0. Now velocity of the stone, or v equals to ds by dt, or that equals to 48 minus 32t, that equals to 0. 48 minus 32t equals to 0, then t equals to 48 by 32, or 3 by 2. Now t equals to 3 by 2, the velocity of the stone equals to 0. Now if t equals to 3 by 2, required displacement of the stone, or maximum height reached of the stone. Now s at t equals to 3 by 2 required. Now 48 into 3 by 2 minus 16 into t square, or 3 by 2 whole square. Now that equals to 24 into 3, 72 minus 2 square 4 into 9, 36, or that equals to 72 minus 36 equals to 36 units. Now first option is correct. If a point P is moving with uniform velocity v, along a straight line AB, O is a point on a perpendicular to AB at A, and a distance L from it, The angular velocity of P about O, if suppose AB, a particle or a point P moves on AB, if suppose certain time it reaches at P. Now there is a point O perpendicular to AB at A, and the distance between O and A given L. Now required the angular velocity about O, angular velocity of P about O. If suppose AP subtend an angle theta at O, required angular velocity of P, it is nothing but d theta by dt. Angular velocity of P equals to d theta by dt, required. Now consider AP equals to x. Now the velocity here, AP equals to x, consider. Now it is nothing but displacement of the x, nothing but displacement of P. Now dx by dt equals to given v, velocity of the point P equals to v, velocity of the point P with uniform velocity v. Now dx by dt equals to v, dx by dt equals to v given. Now required d theta by dt, Now in triangle OAP, tan theta equals to, in triangle OAP, angle A equals to 90, then tan theta equals to opposite side by adjacent L. Now differentiating with respect to t on both sides, tan theta derivative secant square theta into d theta by dt equals to right side derivative. Here the distance between O and A always constant given L, Now 1 by L, that is constant, into derivative of x with respect to t, dx by dt. Now but required to d theta by dt, equals to 1 by L into dx by dt, given v into 1 by secant square theta or cos square theta. Now d theta by dt equals to v by L into cos square theta, in triangle OAP, cos cos theta equals to adjacent side by hypotenuse, adjacent side by hypotenuse, that is nothing but L by OP. Now cos square theta equals to L square by OP square. Now one L get cancel, or that equals to LV by OP square, LV by OP square. Now d theta by dt equals to LV by OP square. Now third option is correct, third option. The point on the parabola x square equals to 8y, the point on the parabola x square equals to 8y, for which the abscissa and ordinate changes at the same rate is. Now require the point on the parabola. The abscissa and ordinate both change in the same rate, means here abscissa x coordinate, ordinate y coordinate, given dx by dt equals to dy by dt. The rate of change in abscissa equals to rate of change in ordinate, that is the given condition. Now x square equals to 8y, differentiate with respect to t on both sides, d by dt of x square equals to 8 into d by dt of y. Now x square derivative 2x into dx by dt, that equals to 8 into dy by dt. In problem given dx by dt and dy by dt both are equal, then dx by dt, dy by dt cancel. Now 2x equals to 8, now x equals to 4. The x coordinate or axis of the point equals to 4. Now x equals to 4, substitute in the equation of the parabola. Now we get 16 equals to 8y, for implies y equals to 2. Therefore the required point is 4 comma 2. The required point 4 comma 2. Now third option is correct. Third option. At what value of an angle the rate of change in sine and tangent of the same angle are equal, same angle are equal. Now if suppose consider the angle is theta, sine theta and tangent nothing but tan theta, both are changes in the same rate, means d by dt of sine theta equals to d by dt of tan theta, but required theta value. The rate of change in sine of angle equals to the rate of change in tan of angle given in problem. Now d by d theta of sine theta equals to cos theta equals to cos theta into d theta by dt equals to differentiation of tan theta equals to secant square theta into d theta by dt. Both sides d theta by dt cancel. Now cos theta equals to secant square theta, but secant square theta equals to 1 by cos square theta. By cross multiplication we get cos cube theta equals to 0. Sorry, cos cube theta equals to 1. Now cos theta equals to 1. Now cos theta equals to 1, then theta equals to 2n pi. Theta equals to 2n pi, then the rate of change in sine equals to the rate of change in tangent. Both are same. Now second option is correct. Second option. If the rate of change of area of the circle equals to the rate of change of its diameter, then its radius. Now area of the circle, if suppose consider radius of the circle equals to r units, radius of the circle equals to r units. Now area of the circle equals to pi r square, area of the circle equals to pi r square, and diameter of the circle equals to 2 into radius, 2 into radius. Now given the rate of change in area of the circle or d by dt of pi r square equals to the rate of change in diameter d by dt of 2r. The rate of change in area of the circle equals to the rate of change in diameter given. Now pi r square derivative 2 pi r into dr by dt, that equals to the rate of change in diameter 2 into dr by dt. Dr by dt get cancel. Now 2 also cancel. pi r equals to 1, then r equals to 1 by pi, then radius of the circle equals to 1 by pi. If r equals to 1 by pi, then area of the rate of change in area of the circle equals to the rate of change in diameter. Then fourth option is correct.